All right, here is the second part of our video about different functional groups. So the next functional group we're talking about here, these are esters. Functional group, or so the class of compound is called ester, and then the functional group is also called ester. These look a little bit like carboxylic acids, except on the other side of the oxygen, instead of having a hydrogen right here, we continue with another carbon chain. And this notation here, R and then R prime, just means that there are two different hydrocarbon chains here. Okay? So an example of an ester, I'm actually going to do two examples, it can be a little bit tricky to name these compounds or to sort of pick out the important features of the structure. So for this one, I'm going to draw 1, 2, 3 oxygen here. And my double bond to oxygen here. Okay, and for this one, like that. Okay, so those actually do look very similar, but the subtle difference between them is key. So on this one, so I've got two parts to my ester. I've got the part of the chain that has the double bond to oxygen, so that would be this part here or this part here. And then I've got the part that doesn't have the double bond to oxygen, okay? And when I name my ester, I look for the part that has that double bond to oxygen. That's my main chain. It doesn't matter if it's the longer piece or not. That is still my main chain. And then the other part, without the double bond to oxygen, I name that as a branch. Okay, so you'll see what this means is that you have your first part of your name, the branch name, so something ill, and then you have the second part of your name, and the ending for that is O8. So here, I've got 3 carbons in my branch part of my chain. So that's a propyl group. And then I've got just 1 carbon on my main chain. That's a methanoate. Now over here, I kind of flipped it. So now there's only 1 carbon in this part of the chain that has no double bond to oxygen. So my branch part is a methyl. And then there's 3 carbons on this side with the double bond to oxygen there. So that's propanoate. I just broke that over 2 lines so it would all fit. Okay? So just when you're naming esters, it's important to look for that detail. Which side has the double bond to oxygen? We name that as the main chain. And then the other side gets named like a branch. Okay? We'll actually when we talk about organic reactions, it's not that hard to make an ester. It's really just a matter of some gentle heating of an alcohol with a carboxylic acid. And this part of the molecule, the branch part, always comes from the alcohol that you use to synthesize the ester, whereas this part comes from the carboxylic acid. Okay, so the way they're named actually kind of reflects how they can be synthesized. Okay, next group here, we've got ethers. And I'm going to go over 2 naming conventions for ethers because both of them come up pretty often. Ethers are what we would call structural isomers of alcohols. So they have oxygen single bonded into the middle of the chain. So this is another situation where our R groups here have to represent hydrocarbon chains. If one of these was just a hydrogen, then it would be an alcohol, not an ether. Okay, so a specific example of an ether, I've always got an oxygen in the middle, and then maybe I'll have 2 carbons on that side and 3 on that side. Well, let's make it 4. I just did one with 3. Okay, so 2 different ways of naming these. One is to just pick look at the 2 chains and sort of name them separately in alphabetical order, kind of like branches. So here, because I've got 2 carbons, I've got an ethyl group, And here, because I've got 4, I've got a butyl group. So I'm just going to list those in alphabetical order. Butyl, ethyl, ether. Okay, one way of naming an ether. Another way, this second way is more useful in situations where you have multiple functional groups. I'm gonna use the space up here to do it. So here we pick the longer chain as our main chain. So that's a butane chain. And then I name this part like it's a branch. Okay, so this, and instead of calling it an ether explicitly, I'm just going to call it something oxy. Okay, so because this has 2 carbons, it would be F-oxy. Okay, so this is F-oxybutane or butyl ethyl ether. Okay, now another place that this naming convention could be useful is if, say, I had my ethoxy group on like the 2nd carbon in my butyl chain, or sorry, right here. Okay, so then I could call it 2-ethoxybutane. It would be easier to use that numbering system in this style of naming than in this style. Okay, so that kind of exhausts the functional groups with oxygen that we are going to cover. And then we're going to talk about 2 different types of functional groups with nitrogen in them. Okay, starting with amines, which are derived from ammonia. And amines have a nitrogen in them. And nitrogen, we know it to be an atom that can make 3 bonds. And we could have one of those bonds to a hydrocarbon, making it a primary amine. We could have 2 of them to hydrocarbon chains, making it a secondary amine. Or we could have all 3 of the bonding spots on nitrogen to hydrocarbon chains. That's a tertiary amine. So I'm gonna try to fit examples of all 3 in here. Sorry if it gets a bit squished. So let's start with a very simple primary amine, the simplest one, which is a nitrogen bonded to a single carbon. Okay, and then obviously all the bonding spots are going to be filled up with hydrogens. I'm actually going to draw this as a full structural formula just so you can see what that looks like. Okay, so my nitrogen has 1 bond to a hydrocarbon chain. That's this right here. I filled up my bonding spots with hydrogens here. And then the other 2 bonding spots in the nitrogen are just filled with hydrogen. So that makes this a primary amine. Okay, because we only have 1 bond to a hydrocarbon chain. And this would be, because there's only 1 carbon there, methane amine. Okay, that's an example of a primary amine. Next would be a secondary amine. So this is an amine that would have 2 bonding spots to hydrocarbon chains. So let's say I have 1 methyl group and 1 ethyl group on my amine. So that means I still need a hydrogen on there. Okay. Now, I have to pick the longest chain that's bonded to the nitrogen as my main chain. So the longer chain here is the ethyl group. So this is going to be an ethane amine. Okay, and then my other hydrocarbon chain here, it gets named, instead of using a number, I use a capital N dash to show that this methyl group is bonded to the nitrogen and not to another carbon. Okay, so that would be N-methylamine, ethane-amine, sorry. Okay, an example of a tertiary amine. So let's see here. I'm going to do 1, 2, 3 carbons on 1, and then let's say 2 methyl groups, okay? So nitrogen can make 3 bonds. All of those bonding spots right now are filled up with hydrocarbon chains. My main chain here has 3 carbons, so that main group here is a propan amine. And then these are both methyl groups, so I'm going to group them together. I'm going to call it N-N-dimethyl propanamine. Okay. Obviously, if one of these was an ethyl group, then maybe it would be N-ethyl and methyl propanamine. I hope you kind of see where this is going. And then my last functional group that I'm going to go over today is called an amide group. So kind of like, this probably looks familiar to you because you've taken some biochem at this point. So this is sort of what happens if you react a carboxylic acid with an amine. So we've got an amine group adjacent to a carbon that's double bonded to an oxygen, sometimes called a carboxamide. And I'm not going to go through like multiple examples, primary, secondary, tertiary here. I'm just going to show you one pretty straightforward example here. Let's do, just because it's we haven't gotten up to 6 carbons in any examples here, let's do 1, 2, 3, 4, 5, 6 carbons in our chain, and then an NH2, and that last, so the carbon that's adjacent to the NH2 group gets a double bond to oxygen to make it an amide. Okay, so then this would be, because there's 6 carbons, hex, no double bonds or triple bonds between the carbons, so hexan amide, because it's got an amide group on the end here. Okay, and that's it. That covers most of the functional groups you need to know. There might be some questions about haloalkanes. So when you incorporate halogens into the chain that I didn't get to on these pages, hopefully you can kind of just figure those out. It's pretty obvious, but if you have any questions, please email me or post them in the Google Classroom. Thanks so much, guys, and please try the practice questions.